Hello, STEM Nation. Jeff here, and welcome to episode number 5 of STEM on Fire, where we interview practicing professionals in the area of science, technology, engineering, and math. Let's start by thanking our sponsor, Audible, which is offering a free audiobook. Just head over to STEMonFireBook.com. That's STEMonFireBook.com to get your free audiobook. And if you're looking for a good book, I'd suggest The 7 Habits of Highly Effective People by Stephen Covey. Now let's get fired up today with our guest Karen, and I hope our chat will help ignite your passion towards a STEM career. Karen Bartleson earned a Bachelor of Science degree in Engineering Science with a concentration in Electronics Engineering in 1980 from California Polytechnic State University. She has over 35 years of experience in the semiconductor industry, which are computer chips, specifically in electronic design automation. She was Senior Director of Corporate Programs and Initiatives at Synopsys, which is an electronic design automation company. And currently, Karen is the President and CEO of IEEE, which is the Institute of Electrical and Electronics Engineers. Welcome to the show, Karen.
Good morning, Jeff. It's really nice to be here. Thanks for this great opportunity. I'm excited.
Sure, you're welcome. So, Karen, for someone not familiar with engineering science or electronic engineering, can you give some examples of career opportunities? And in this degree, is this different than electrical engineering? And then we'll delve into your specific area of expertise.
So engineering science is a very broad field of study. I studied electrical engineering, electronics, civil engineering, mechanical engineering, chemical engineering, all of this because what I really wanted to do was be a biomedical engineer. But way back in the 1980s, it was too new of a field, so we didn't really have the opportunity to study it. So instead, I studied all the different disciplines. I chose electronics to concentrate in because little transistors and microelectronics were fascinating to me. And that is different than electrical engineering. Electrical engineering is power plants and three-way distribution of electricity. So electronics, now we call it computer chips, was what still fascinates me to this day.
So with that, your experience was in electronic design automation, or EDA, so that the tools that engineers would use to design, I'll say, electronics. Can you delve into more specifics on that?
Certainly. So imagine a computer chip that's the size of your thumbnail that has 1 billion little switches in there, 1 billion transistors. So it's impossible to do this design by hand, to figure out if you're making a microprocessor or a cell phone chip, or something in your computer or in your VCR, whatever the chip is going to do. So we wrote software that would automatically simulate the behavior of your chip. You describe in a high-level language, I want my chip to do something special. And then automatically it would create that configuration for you. It would simulate it for you. And then when it came time to actually build the chip, it would figure out how to lay out the little pieces and connect them all together. So it was all done by computer-aided design, basically. Pretty fascinating field that I went into.
So did you actually develop, I'll say, software to do this implementation, or were you in more of a management role for this?
Well, I started off as an actual software engineer, and we were writing the software itself. I was writing a simulator and other types of software. Then I was writing models that would model the behavior of a transistor, so actually doing the work. And then after a few years, I went into management, continued to write software, but frankly, I haven't written any real software in a long time because once you get into management, you become more responsible for business, for project management, for personnel, for strategy. And of course, now with IEEE, I don't do any real coding because I'm going all over the world representing the field of engineering and science to people at governments and universities and conferences and just doing things that I never imagined I'd be able to do.
Yeah, I think that's fantastic. I mean, you transitioned from a engineer, I'll say, doing a lot of the work, the software engineering, the modeling, into management, and now you've transitioned into the CEO of IEEE. Can you delve into a little bit more of what you actually do for IEEE?
Sure. And for people who are not familiar with IEEE, we are the world's largest technical professional society. We have over 420,000 members in 190 countries around the world. And we are involved in much more than just electrical and electronic engineering. We have physicists, we have people working on the Internet of Things, cloud computing, smart cities. I mean, you name it, and IEEE members are involved in all of those kinds of fields. So as the president and CEO, I am responsible, first of all, for the board of directors. So we set strategy, we make sure the strategy is executed. We work very closely with IEEE's professional staff. There are about 1,200 employees that work at IEEE, and they are sort of the heart of getting the work done in conjunction with all the volunteers of IEEE. The other thing that I'm responsible for is helping to spread the word about who IEEE is, why the engineering profession and scientific professions are so important to everyone. And for instance, in May, I was in Africa for 3 weeks because what we want to do is help Africa's engineering fields, and they call it ICT, the information and communication technology fields. We want to help them grow because they see that as an opportunity to boost their economy, to bring modern kinds of jobs to Africa. So it's really exciting, and that's my role, is to go and meet with government ministers and to present at conferences, to talk about our field, and frankly, to interest people in the STEM area so that we can continue to grow all over the world the exciting fields that we belong to. And then I'll stop for a minute, but first I want to say what IEEE's motto is, our vision. It's advancing technology for the benefit of humanity, and we stress the benefit of humanity is the most important part of advancing technology.
Yeah, thanks for that, Karen. So, when I went to college, I learned about IEEE when I was a freshman. Can you be a high school student and belong to IEEE?
Well, actually, we're thinking about that because we know that in order to really get people excited, we want to start at high school and even grade school levels. But IEEE today does not have a high school level membership. We've been talking about it this year of maybe creating a junior membership of some kind. But our memberships do start at a student level in college and then go on to what we call a young professional. So this would be 15 years after your first degree. And then you go on to become a senior member. And if you are highly qualified, you become a fellow, which is the highest level at IEEE. That's not to say that we don't have a lot of offerings for high school students. We have a very important website. It's called tryengineering.org. It's where young people can go and see what would it be like to be an engineer. What would my salary be? What would I do? And it's very important for us to encourage high school students to do that. The other thing that we do is we have teacher in-service programs. This is where we, quote, train the trainer. So if the high school the high school teachers understand what engineering is and how exciting it can be, then they can pass on that passion to their students. So we're definitely plugged in, but high school students aren't really members yet. They will be when they get to college.
Thanks, Karen. Hey, we're going to move on here a bit. We're going to get pretty specific. So, Karen, what is one thing that has you fired up about engineering, and where do you see it headed?
The one thing that has me fired up, which is really interesting, and I think you might be surprised, that is the area of ethics in technology. IEEE is just now starting to enter into this area because we believe that engineering is a good thing, but we need to think about the ethical considerations before we build products and before we design solutions. So we're now working on 11 active projects that will create standards, if you like, standards that say these are the ethical things that we need to think about as we start the design of a new product or of a new solution. And so to me, this is what's most exciting, what has me most fired up. It leads into other areas that IEEE has been involved in for several years. That would be the area of global public policy. How can we as technologists educate policymakers so that when they create regulations and laws, they do it with the understanding of technology so that they do the very best thing that they can for their local citizens as well as for the global population.
Yeah, I imagine with artificial intelligence really taking off, the item of ethics really comes into play and where that's going to go. So that's interesting. That's not what I would have expected as having you most fired up.
Yeah, artificial intelligence and autonomous vehicles are the two areas that we're first looking at for ethics in technology. And we published a very important work recently called Ethically Aligned Design, and I invite everybody to go search for Ethically Aligned Design by IEEE. Give us feedback because we're now in development for version 2, taking feedback from the entire community. So it's a really exciting piece that we've put out.
All right, and that'll be in the show notes, so you can check it out there. So, Karen, we're going to move into a story, an aha moment you've had, something that might help our STEM nation. Can you take us to a moment in time of an incredible aha moment you've had at work or your personal life and tell us the story and how you turned that aha moment into success?
I'll tell you my first aha moment. That was when I was, I think it was my second year in college, and I was taking math and science courses. Frankly, I had never heard of the word engineering before. I didn't know what it was. I grew up in a family. My father was in the Air Force, and my mom was a bit of a scientist herself, but engineering was something that I was unfamiliar with. So my aha moment was when the Society of Women Engineers invited all of the young girls studying math and science classes at my university to come to a meeting one evening, and they told us all about what engineering was. Well, I was hooked. I loved math and science. You put it together and you make things and solve problems. But I went to class. I switched my major. I went to class, and I looked around the room, and oh my God, I was the only girl. So that aha moment was a shock to me. What have I done? But, I turned it into a success because I thought, this is what I love, and I'm passionate about it. And frankly, I was good at it. I got excellent grades. And the boys were very polite and generally helpful. And so I had to use courage to be, someone who was really different. My voice sounded different. I looked different. I felt different. But being persistent and having courage to keep on going, I think was the biggest success ever. I look back on my career and I say, wow, how did I get here? It's like the Talking Heads song, is this my wonderful life? Well, it turned out really great for me because of that aha moment of I love math and science and I want to do something great about it.
Yeah, and I think that's changing hopefully going forward. I think the Society of Women Engineers is growing, and there's definitely a lot more females heading into the engineering profession, which is really awesome because if you have a field just dominated by, I'll say, by males, you're not going to get the insights from other folks. So I encourage all you females out there that are thinking about STEM and going, well, girls really don't go into engineering. You know what? Girls definitely go into engineering. We've got Karen on the podcast here as an example of that. So drive forward, be successful, go into engineering, go into math-related or science-related fields, and you'll be super successful. So, Karen, we're going to transition now into a topic that's front and center on the minds of STEM Nation and discuss what it takes to get through college and be successful with these rigorous STEM curriculums. So, Karen, if you could go back in time, what would you tell your 18-year-old self as you're heading off to college? Some things that you knew back then or wish you knew back then that would help our STEMers launch into college successfully?
I think one of the things that I would tell myself again was don't pass over opportunities. When I was in college, I took the most interesting classes just for the heck of it. I know I took about 7 years to go through college because I wanted to learn so much. And I did work study and, grants and loans and things like that to make it through. But I would say have courage and try different things and find what your passion really is. You might surprise yourself that you love microbiology. I studied microbiology for a little while because I loved putting germs into different test tubes and watching things grow. I guess I'm kind of a nerd at heart. I just loved everything. But that whole idea that I mentioned earlier about having courage, I think is very important for anybody to get through college. My mom used to say something that was extremely helpful to me, and it still is. She said, what's the worst thing that can happen? So if you have an opportunity or there's a challenge that's facing you and you get scared, ask yourself what's the worst that can happen. And oftentimes it's really not that bad and the risk is low for you to go ahead and just give something a try. So in college, what's the worst that can happen if you take a really hard class? Well, you don't understand what's going on and you end up dropping. Well, that's not terrible. I dropped a couple of classes because I was totally lost. And so, I'd say, ask yourself what's the worst that can happen and take those risks and try different things. And you'll be amazed at the kinds of things that you can do.
Yeah, you got to go off and you have to try. And I'll say, probably one of the best things that could happen is you fail and then you learn from that failure. And you also find out things that you just really don't like. And you'll never know unless you go off and try it. Karen, we're going to go to some skills or attributes. What do you think are needed for STEMers to be successful as they launch from college into their careers?
I think for STEMers, when they start their career, it's important that they connect with other people like them, because when you start working, it's a different world, and there's a bunch of old people. I remember my first bosses, they were 40 years old. Oh my God, they were just ancient.
Yeah, that's not very ancient anymore.
Actually, right now, to me, that's extremely young.
Yeah.
But having some friends that you work with and that you can talk to and that you can understand the challenges, I think is really important when you first start your job. We also talk a lot about mentoring these days. Now, I never had a mentor because the concept didn't exist. But I would encourage young people when they're first starting out, find someone who's been around for a few years, maybe 5 years or 10 years, and ask them if they wouldn't mind spending a little bit of time with you. Maybe, an hour a week, an hour a month, just a little bit of time to give you some insights as to how they made it through their first 5 or 10 years. So I think looking for a mentor is a very important thing to do as well.
Yep, go get a mentor. I think a lot of companies now, they'll have a kind of a mentorship program. And if your company that you go off and work for doesn't, just, hang out with a couple of people, just ask them. And more than likely, they're going to be more than willing to help you out. So reach out, get some help, and find a mentor. So Karen, are you ready for the lightning round?
Sure.
All right.
What's the worst that can happen?
What's the worst that can happen is you're going to have to drop. That's what I hear. What is the best piece of advice you've ever received?
I think it's to really get over your fears and to, for me as a woman, I would start my conversations by, you might not think this is a good idea, but, and one of my good friends, who was a guy, by the way, said, Karen, don't start your sentences that way because you immediately undermine yourself. So as women, we need to just put ourselves out there rather than starting with something that's self-deprecating.
Yeah, start with confidence.
Yeah.
So what's a personal habit that contributes to your success?
I think my habit of being optimistic, I always look for positive things. I look for how things can work, not why they won't. So it's an optimism that really keeps me going all the time.
And what's your favorite internet resource or phone app and why?
My phone app that I really like, see, I'm such a nerd, is called Earthquake Alert, because when I'm bored or just wondering what's going on in the world, I check out all the earthquakes. The planet we live on is constantly in motion, and it makes me excited. Maybe it gives me energy too. But beyond that, seriously, I use Google constantly. I don't know how I could survive without Google these days because I have all the knowledge of humanity at my fingertips.
Yeah, and that wasn't the case back when I graduated, right? There was no internet, there was no email, and it was challenging back then. And yeah, it's amazing what you have at your fingertips today. You basically have everything.
Yeah. Although you do have to use common sense because sometimes the answers you get are just plain wrong. And so you have to still be able to think on your own when you're off there Googling for information.
Yeah, you have to use common sense, absolutely. And Karen, what is one book you recommend and why?
So Jeff, this is the most amazing coincidence. The book that you recommended at the beginning of this podcast, The 7 Habits of Highly Effective People, I highly recommend that, even to this day. There's a skill in there that's called seek first to understand before being understood. I use that all the time. I actually met and invited Stephen Covey. This is Stephen M.R. Covey, so Stephen Covey's son, who's now written a book called The Speed of Trust, and that's another excellent book. He gave a seminar to the IEEE Board of Directors on how important trust is. So those 2 books, I think, are one of the most important ones that anybody can read.
Yeah, and I'll say, STEM Nation, when you read a book, you don't just read it once. At least that's what I find out, is I'll get the book on audio, and I'll listen to it from time to time, maybe even a couple times a year, because depending upon where you're at in your learning process, you're going to pick up new things that you weren't able to pick up the first time you listened to or read a book. So that would be one that I'd recommend to get on audio and listen to it whenever you think you need to listen to it, a couple times a year. So Karen, as we wrap up here, can you share a parting piece of guidance for STEM Nation, and then we'll say goodbye?
Yes, I think STEM Nation, everybody out there, let's talk about how science and technology can help the world. I think when we talk to our policymakers, when we get involved in government, as technologists and engineers and scientists and mathematicians, we can try to bring some order to this crazy world that we're living in, to calm people down and say, let's look at the real issues at hand, things like climate change and pollution. And my favorite is, or my least favorite is, the amount of plastic that we're producing. Because by the year 2050, there will be more plastic in our oceans than fish by weight. We're slowly destroying this beautiful planet we live on. And so all of us who have a STEM interest or STEM experience, please let's work with our policymakers to fix things and make the world better for the next generation.
Thank you for your insights, Karen. I appreciate your time. And with that, we'll say goodbye.
Goodbye, everyone. Thank you, Jeff.
I hope you enjoyed our discussion today with Karen. Head on over to STEMonfire.com, subscribe to the email list to keep up with the latest happenings, and be sure to subscribe to the podcast on iTunes, Stitcher, or Google Play. Tune in next week where we talk with Tracy Fanara, an environmental engineer who starred in Mythbusters The Search. Until next time, I hope this chat has helped ignite your passion towards a STEM career.